1, it could have range 2, 3, 4, etc. up to D. But here there is a constraint, and as we will see, yes, yes, ma'am. So the range TV is contained in the kernel of T. This is the thing. On the other hand, we have dimension of kernel of T plus dimension of the range of T. Sorry, dimension of the image of T. In other words, the range of T. Nullity plus the rank. This is the rank nullity theorem. Is equal to D. Okay, so it follows that dimension of TV, it cannot be more than, it cannot exceed half the dimension of D, because if it exceeds half the dimension, this will be even more than that, or equal or more. So if this is more than half, this is also more than half, so the total adds up to more than D, which is a contradiction. Okay, it follows that the
less than or equal to D by 2.
Yes, it follows that. Thank you, ma'am. I'll just write it like you said. Okay. So let's. I'll leave that as being clear, unless you tell me that actually all these values are possible, meaning the values taken are 0, 1, 2, etc., up to the floor of D by 2. Right? This indicates the floor of smallest integer, largest integer less than or equal to D by 2. Okay. So these are the values taken. Okay. Very good. Now I want to ask you, V has dimension D. Let's jack up let's up the stakes, as they say. Linear. What do you expect I'll write? Do you want to guess a question? Slightly more difficult than this. Here it is. Then same question. Now what? So I want you to think about this question. Take your time. This is not explicitly there in the exercises, but it is there implicitly. If you do the exercises, then you will in particular have to understand this. Let us fix D to be some number like 100 or 20 or something like that. I hope you understand like I was saying last time, more than solving the question, I hope you understand the significance of the question. Right, and let me tell you the one way of doing this question, which you could have used for the previous one also. So you can use the Jordan canonical form. Okay, any comments? If this were a live lecture, I would just be quiet for 5 minutes. But since it is, yeah, yes, ma'am. Does somebody want to respond? I thought I heard a sound. So more explicitly, so let's do dimension of, so let's do dimension of TV, which is going to be bigger than dimension of T square V. Okay, so let's say this is D, the dimension of V, which is D. Right, this is going to be bigger than or equal to dimension of T cubed V, which is 0, because T cubed is 0. So there are these two numbers in between. So I'm asking for this as well. So this is what is being asked. In addition, you can ask for this as well. What values can this take? Dimension of T squared. So for example, can a dimension of T be D? Can it have full dimension? Can the range be full?
No.
Why not?
0 is the one of the eigenvalue, therefore kernel contains at least one non-zero vector.
Yeah, right, correct. That's absolutely right. No, the other way of saying it would be that if T were onto, it would be an invertible linear transformation. Right? Therefore, there is no way T cubed is going to be 0. T squared, T cubed, T to the 4, T to the 5, T to the 6, all of them are going to be invertible, continue to be invertible. Yeah. So clearly it cannot be D. Okay. Can it be 0?
No.
Why not?
Because T cube is 0. That is a minimum number such that T cube is 0.
No, I didn't say that. I didn't say that. It's not said that T cubed, it's T cubed equal to 0 is always given. I'm not saying 3 is the minimum number such that T cubed is 0. Here also we didn't say T square. I mean, I'm not saying, you understand what I'm saying. Yeah. T T square is 0. T could very well be 0. That's not ruled out. That's not excluded. So can it be 0? So what does it mean when the range is 0?
This is zero map.
Zero matrix. So it could very well be the zero matrix, right? No problem. Zero matrix has this property. Its cube is 0, right? So it could very well be 0. Okay. So 0 is a possibility. D is not a possibility. So what are the possibilities?
One up to D minus RD.
1 up to
D.
I mean 0 is included, right? Anomaly, are you saying? I mean 0 should also be included, right? Are you saying this? Up to this? Is that your answer?
Yeah. Except 0.
Except one. Sorry.
Okay. If you say zero matrix.
Yeah. Zero is okay, right? It can be the zero matrix. The zero matrix has this property, so you have to allow 0. Is that clear enough? Here also, same. We have allowed 0. Do you agree, Anomaly? Does it make sense?
Yes.
I can explain. Yeah. Okay. So
Yeah.
Is this your answer?
Yeah, I think so.
Okay. So guess. Let me put it. Okay. So can you construct? Let's take T to be 4. I mean D to be 4, right? And I want. Suppose I take rank of T to be 3, right? Okay, can you construct such a matrix with T cubed equal to 0? If rank is, okay, so I claim you cannot. Okay, let me give you a proof. Okay, so to get you started. Rank T is 3. What does that mean about the kernel?
Should be one dimension.
Dimensional. Okay, kernel of T is dimensional. Okay, look at now. See, you have TV, right? And you have map going to T square B, right? Correct? So, sorry, kernel. Oh. Sorry. Okay, sorry, I missed. Look at this. So, what can the kernel of this map be? It has to be belong to the kernel of this. Also is. So kernel of. So what is this? Here, kernel of T restricted to TV, dimension of this is less than or equal to dimension of the kernel of T, right? Which is equal to 1. So this kernel here, from here to here, is at most 1. So what can be the rank of this?
1.
No. Wait a second. This is rank how much? This is the dimension is how much? This dimension is
3.
and here the kernel has rank. Kernel is 1 or 0. Dimension
So
of the
maximum
kernel is
2.
maximum 2, but minimum. No, sorry, no, not maximum 2, but minimum 2.
Yeah.
Okay, this can be 3 or 2, right? And now look at t square v to t cubed v. Right, and then again consider t. T takes from here to here. Right, what is the dimension of the kernel of this? Again, it's less than dimension of kernel of t, which is 1. Sorry, which is equal to 1. Okay, so this has 3 or 2, and the kernel is dimension 1. So what can this be? What are the possibilities for this? The rank of this, or the dimension of that? Kernel is at most 1. It can be 0 or 1. So it can be, if it is 3 and 0, and the kernel is 0, then it's 3. If it is 3 and the kernel is dimension 1, then it is 2. If it is 2 and the kernel is dimension 0, then it is 2. If it is 2 and the kernel is dimension 1, then it is 1. So these are the 3 possibilities. So it cannot be 0. Is this argument clear? Okay. So the thing is, it looks like a complicated argument, right? See, the reason why we have theorems in mathematics is that they help us. It's like having a high-level language in computers, right? What we call a human language, right? You have machine language, which means a code that a computer reads, for example, it is only in terms of zeros and ones, right? It's very explicit, but that's something you and I cannot read. Similarly, in mathematics, this is a low-level proof, in the sense that you have to get your hands very dirty, and it's not clear exactly how you could, possibly do the case when, say, I give you t to the 100 equal to 0, which is next I'm going to ask you t to the 4 or t to the 5 in general. This has some dimension, and this has some, I'll put some number here, right? Less than d. So let's say v has dimension 100 and t to the 50 is 0. Then what are the possibilities for dimension t of v, t square of v, dimension t cubed of v, etc. Okay, and then you'll have to do this analysis repeatedly. I mean, it's not clear how this thing is going to. It looks a bit complicated. That's why we have the JCF. Right? If you think of the JCF, then it becomes quite clear, the answer. Okay, so what does JCF tell us? What does the Jordan canonical form tell us? So every matrix or every linear transformation on a finite dimensional vector space, or every square matrix, in other words, has it has a unique form, but in particular, I mean, the uniqueness is not so relevant here, but the existence, that it has a Jordan canonical form. Now, what does that mean? It is similar. You can choose a basis of V such that the matrix of T is in Jordan form, right? Okay. So use that, please. So tell me what possible Jordan forms can this have? So I give you an operator on a d-dimensional vector space. Let's take d equal to 4, say, and t cubed is 0. Then what does the Jordan canonical form look like?
Suppose t cube is 0, but t square is not 0, assuming that 3 is the least power.
Okay. Okay.
And then therefore x cube is the minimal polynomial.
Mhm.
Therefore, you have black maximum is 3 by 3 matrix.
Mhm. No, so what does, okay, you don't need to do that, anomaly. Let's not do that. Let's just say t cubed is 0. Right. I mean, you can do that if you wish, but there is not necessary for that. So what are the possible? So if I take an operator on a 4-dimensional vector space and it's nilpotent, right? Nilpotent means some power is 0. What are the possible Jordan canonical forms? So let me repeat that question. Let's understand that. Okay, so here is the question. Suppose I take 4 by 4 nilpotent matrices. What are the possible Jordan canonical forms? That's the question. Yes, Annamalai, please go ahead now.
So you take the upper triangle matrix, above the diagonal is 1, 1.
1 more. Yeah, and on the diagonal?
That is 0.
That is 0. Yeah. Okay. And what are the possibilities for 4 cross 4 matrices?
Yeah, if you take the 4 by 4 matrix, then
4 by
above the
4.
diagonals, there are 3 ones.
Okay, that is one possibility. So remember that a Jordan canonical form means breaks up into Jordan blocks, right? So here, for example, the whole thing could be one Jordan block. So this is one possibility, right? Okay. Okay, that's one possibility. What are the other possibilities?
You take the 3 by 3 matrix.
3 by 3 and a 1 by 1. Okay.
That is 0. Yeah.
This is 0. Okay. And what are here?
0, 0, 1, 1.
Very good. Okay. Okay, that's one possibility. What is the next possibility?
Is everything is 1, 1, 1. Oh, sorry. Yeah, 1 by 1 black.
Let's go systematically. So,
Or the first one is only 1 by 1. The last one is 3 by 3.
That is the same as this because
the same is.
See, okay. Let me also. I mean, I didn't mention this because I thought it's something you would know. But the Jordan blocks are parameter. I mean, there are as many Jordan blocks as there are partitions of 4, right? So this is 4 is equal to 4. This is 3 plus 1. What are the other ways of writing 4?
2 plus 2.
2 plus 2. Okay. Okay. And then so 2 plus 2, what would that look like? That would look like 0, 0, 1, 0, like this. Of course, these are 0, right? Okay. This is 2 plus 2. What are the other ways of writing it?
All are 1. 1, 1, 1 plus.
Are you sure? There's one more.
1 plus 1 plus 2. Yeah.
Right? So this is a systematic way of writing all of them. So this is 0, 1, 0, 0, 0, 0. Okay, of course, all the non-diagonal entries are 0. Okay, and finally,
0 matrix.
1 plus 1. Indeed, yes, right, very good. That's the 0 matrix. So here all the blocks are 4 blocks like that. Okay, these are the possibilities. Now I am given that. Okay, is this okay? First of all, now what I am saying is use this to answer this question. What is eliminated? What possibility is eliminated given that t cubed is 0? What is T cubed in this case? What is the matrix of T cubed in this case? You don't have to actually do it. I mean, you can see it and say
Not non-zero.
it's non-zero, right? What is it? What is it in fact?
T power 4 is 0.
T power 4 is 0. But can you tell me the T cubed matrix? What does the T cube look like? The cubed of this matrix look like?
I think I can take above this again one more diagonal above the diagonal. Non-zero entry. Diagonal elements 0. Above the diagonals are 0.
Okay.
And then you take some non-zero entries there.
Here. You have to tell me what those entries are without actually doing it. See, this is the way to do it. I mean, see, you're not using the full knowledge. So, for example, what is the first column? The first column will be the image of the first vector, right? Under the operation. Now, T itself kills it. So, T to the 4, T to the cube definitely kills this. Right? So, if this is A, this is what we are doing. A cubed is what we are trying. Right? So, let's say the matrix are V1, V2, V3, V4. That's the basis. So A of V1 is 0. So what is this? A cubed of V1. That is definitely 0. Now, what is A of V2? It is equal to, so let me draw a picture here. You see here, V4, what is the image of V4 under A? By the matrix, given that it is the matrix. Everything is 0 except, except just above the diagonal. Where is V4 mapped to?
V3.
V3. Very good. What is V3 mapped to?
V2.
V2. Where is V2 mapped to?
V1.
And where is V1 mapped to?
0.
Okay. So this is all A. So what is the second column? The second column will be the image of V2. If I have to apply A 3 times. If I apply it once, what do I get? V1.
V1.
Second time, already it is 0. Third time, it will be 0, right? So that's 0. What will happen to V3 when I apply A 3 times? That's the third column. What happens? 1, 2, 3 is 0. What happens to V4 when I apply A 3 times? It becomes V3,
V1.
V2, V1. So the answer is this. Right? I mean, you should not always multiply matrices necessarily. Right? This is, I mean, this is something that you should use this thing that you know from the way you construct matrices attached to linear transformations. Okay? Okay, right. So A cubed is 0 here. The A cubed is non-zero here. So this is eliminated, right? So this is not possible because T cubed is 0. I'm using A as the matrix associated to T. Okay, because T cubed is 0. Here T cubed, A cubed is non-zero, right? Okay. These are the 3 possibilities. These are the 4 possibilities left. Right. So what are the possibilities for a dimension of? So here, what is dimension of? So here, what is the rank? What is the kernel and what is the rank?
2 and 2.
2 and 2. Okay. So here, dimension of TV. So let's write. I'll use a different color here. Okay. Dimension of. So okay. Let's compute. So for each of these possibilities, let me call them 1, 2, 3, 4. Let's compute dimension of. Sorry. Okay, I'll make a table here. Okay, so there is dimension of TV, dimension of T square V, dimension of T cubed V, of course, is 0, right? Okay, so here is 1, 2, 3. Okay. What is the dimension of TV? So let me use a different color here. What is the dimension of TV here? In this one, in the first one? Anomaly already
Two.
said it. 2. What is the dimension of T squared? So when I square this matrix, what happens? You don't have to think of squaring the matrix. You think of what is happening to the vectors. What happens to V1? When I apply T square?
Zero.
0. What happens to V2 when I apply T square?
Zero.
What happens to apply V3 when I apply T square?
V1.
V1. Okay. What happens to V4 when I apply T square?
V2.
Huh?
No.
V
0.
So 0. Right. Okay. So what is the answer? What is dimension of T square? If I look at this basis and apply T square, 3 of them are becoming 0. V1 is becoming 0, V2 is becoming 0, V4 is becoming 0. V3 is the only non-zero, it is going to V1, right? So what is the dimension of T square?
1.
Okay. 1. Okay. That's one possibility. How about here? What's the dimension of TV?
2.
2. Okay. What's the dimension of T squared? T square here.
One.
Why?
No.
What
V1
is
goes to
happening? V1 goes to what? What happens to V1?
So it will
0.
become zero matrix.
Yeah. I mean, don't multiply these matrices, although that is easy to do. Just think in terms, I mean, that's one way of doing it. If you see it immediately, that's okay. But in a large example, if you are, if you are going to multiply, it's going to be difficult. You just see it as follows. V1 goes to 0. See, V2, what happens to V2? V2 goes to V1 when I apply T. When I apply T again, it's going to become 0, right? So V3 is already 0 if I apply T. V4 will become V3 when I apply T once, but the second time I apply it, it becomes 0. So this is 0. Okay, so what about here?
1.
And the next one? Tell me the other entries, please.
Zero. 0. 0.
Okay, so it cannot be 3 dimension. So the possibilities are, these are the possibilities for the numbers, right? Dimension of TV cannot be 3. Okay, so that is in the case 4. But how do you think of the general case? For a, say, 10 by 10 matrix, I'm given T cubed is 0. So what does it mean? What does it, how do I compute these possibilities? So now let's up the stakes again. Let's take a, suppose, so this This is for 4 by 4. Let's say D equals 10. Take that. Again, T cubed is 0. What are the possible JCFs? Now, you don't have to write the JCFs. You don't have to write the matrices like this, right? You just have to write these.
You take the partition of 10,
you write the
including
partitions.
4.
Yeah. You take all the partitions of 10 such that.
And one of the entries should be 4.
Why should be 4?
Oh, sorry, here 3. Okay.
One of the
Three.
entries should be
3.
Why? Again, you are making the mistake. Mistake meaning T cubed is 0. I'm not saying T could be itself 0. That's not ruled out. All you are saying is T cubed is 0. So here, for example, here you are taking this 0 matrix. That's allowed, right? Is that okay, Annamalai?
Yes.
Okay. So what? Okay, you take all partitions of 10, but then what is the condition? What is the restriction? Not that one of the entries must be, one of the parts must be 3, but if you had a part like this, 4, will T cubed be 0? If you had a part like this, will T cubed be 0? No, right? Because this the cube of this matrix is not 0. Okay, so what does that mean about the partitions that, what kind of partitions of 10 should I take? Normally, you just had
Proper
it.
sums.
Yes.
Proper sums, except 10.
Why, if it is 9, will T cubed be 0? If I had a 9 plus 1, there will be a 9 by 9 matrix.
So we have to consider matrices less than the order of 3.
Less than?
Order 3.
The part should be less than 3. 3 or less.
3 or less.
No part should be more than 4. That is that correct? Do you agree with that, everyone? In the moment you have a part, see, there will be lots of JCFs possible for this, right? 10 itself, 10, 9 plus 1, 8 plus 2, 8 plus 1 plus 1, 7 plus 3, 7 plus 2 plus 1, 7 plus 1 plus 1 plus 1, etc. Okay. Now, the moment, but I am putting the condition that T cubed is 0. The moment there is a part that is bigger than 3, strictly bigger than 3, it is not going to be, its cube is not going to be 0. Okay. So the JCFs will correspond to partitions of 10 with every part being less than 3. So what are the possibilities? Can somebody please tell me what those partitions are of 10? You see, I'm listing the partitions systematically here. There's some method to it. This is not the only method. I mean, I'm putting the bigger number first, smaller numbers later, but you can do it the other way if you want. But let's keep to this convention, bigger number first. So let me start here. So one possibility is
3 plus 3 plus 1.
3 plus 3 plus 3 plus 1. Okay. That's one possibility. Okay. What are the other possibilities?
3 plus 3 plus 2 plus 2.
3 plus 3 plus 2 plus 2. Right. And then?
3 plus 3, 1 plus 1 plus 1.
3 plus 3,
4 ones.
I would say 2 plus 1 plus 1. Next.
Yes.
Right? And then 3 plus 3 plus 1 plus 1 plus 1 plus 1. Okay? Is it all right?
Yes.
Yes, sir.
Okay. Okay. Now we are done with 2 3s, right? We are done with 2 3s. Right? Now let's go to 1 3. Okay. So now the maximum number of 2s. So it's 2 plus 2 plus 2 plus 1. That finishes 3 3s and 2 2s. Sorry, 1 3 and 3 2s. Now 3 plus 2 plus 2 plus 1 plus 1 plus 1. Okay. And then next one will be, I'm going in with some logic. What should be the next one?
3 plus 2,
Hmm.
1 plus 1 plus 1.
1 plus 1 plus 1, 5 times. Okay. Okay. And then 3 plus,
All integer.
so 1 plus 1 plus 1, 7 times. Okay, you can write this as 1 power 7 or something like that. So you know, if you are getting to, you can use some notation like this, right? If you want. Okay, don't get confused. This is not 3 power 1, 2 power 1 into 1. You know, the same notation in mathematics can be used for different things. Okay, depending on the context. So, okay. So now what is left? So 2s, right? There is a lot of 2s. So let me write them in this notation. Either there are 5 2s, or there are 4 2s and 2 1s, and either 3 2s and 4 4s, 2 2s and 6 4. Sorry, 3 2s and 4 1s, 2 2s and 6 1s, 1 2 and 8 1, or all 1s. Right? These are the possibilities. Right? There are so many possibilities. Now, for each one of them, we can list what dimension of TV, T square V, T cubed V is. Right? Okay, let's do that. So for each one of these, I'm going to list. So let me do a different kind of tabulation now. Right? So I'm going to write dimension of TV in this color. And I'm going to write dimension of T square V in this color. So if I write, okay, if I write here, so one thing in this color and one thing in this color, that means that will be the dimension of TV and that will be the dimension of T square. Okay, very good. So what will be the dimension of TV in this case? So now it's very interesting, right? You have to really imagine. You cannot, I mean, I wouldn't advise drawing a 10 by 10 matrix and doing it. You have to now just imagine it in your head and do it. So we have V1, V2, V3, V4, V5, V6, V7, V8, V9, V10, right? What does this mean? 3 plus 3 plus 3 plus 1. So what is the dimension of the kernel? How many are going to 0? Which vectors are going to 0?
V10 0.
V10 is 0. Then how about V1?
V1 is going to V1.
V1?
Sorry,
V1
goes
is
to
not
0.
going to 0.
Goes 0.
V1 is not going to V1. V1 is also going to 0. Then
V2 goes to V1.
V2 goes to V1. V3 goes to
V4.
V2.
V2 goes to
V3 goes to V2, correct?
yes.
V4?
Yeah, generally we can say Vi goes to Vi plus 1, where I is greater than or equal to 2, less than or equal to 9.
Let's not. So, okay. No. First of all, Vi goes to Vi minus 1.
Yeah.
That's, but not everything. It's 3 plus 3 plus 3 plus 1. Okay. So you know, see, the other thing is you generalize too quickly sometimes. My observation is you have to, you know, don't say, oh, now I'm going to do this generally. I don't think you can. I mean, just do it explicitly. So what about V4 in this case? What does it go to? See, it's a 3 by 3 block. So that one is missing there. There is a 0 there, right? So so there is a 3 by 3 block here. And then there is a 3 by 3 block. So this was V1, V2, V3, V4, right? V4, if you look at this is 0. And here it will be like this. So what does V4 go to?
0.
Look at 0. What is the other thing that goes to 0 here?
V7.
V7. So which are the ones that are going to 0?
It's V1, V4, V7, V9. Sorry, V10.
V10. V1, V4, V7, V10 are going to 0. Okay. So the kernel is at least 4-dimensional. But is it exactly 4-dimensional? What about the rest of the vectors? What is the image? What is the range? What is the basis for the range? How many of these vectors belong to the range?
6 vectors.
Which ones?
V2.
V2 doesn't. Okay. Go on.
V2, V3, V5.
No. Wait a second. No. V3 does not belong to the range. So V2 goes to V1. So V1 belongs to the range. V3 goes to V2. So V2 belongs to the range. I understand what you're saying. V2 is in fact mapping to V1. V3 is mapping to V2. Right? So in the range, what you have, the image is V1, V2. Yes. And then you understand the difference, right?
Yes.
I agree with what you're saying. V2 is going to V1, V3 is going to V2. But I'm asking for a basis of the range space, right? So that will be V1. V1 is the image of V2, for example. Okay. And then V2, is V2 in the range? Yes, because V3 is going to V2. Okay. Okay. Is V3 in the range? Is anything going to V3? Is anything going to V3? How do you answer that question? What does V4 go to?
0.
0. Okay. V5 goes to V4. V6 goes to V5. V7 goes to 0. V8 goes to V7. V9 goes to V8. Right? V10 goes to 0. Is anything, see, look at another way of thinking about it is look at this row, right? The third row is full of zeros, right? Because this matrix looks like this. So if I look at the third row here, it is full of zeros. So nothing goes to V3. Right? So V3 is missing from the range. Okay. Anyway, so what is it? So what is the basis for the range? V1, V2. Let's go on. Is V4 in the range?
Yes.
Okay. So I'm going to write kernel of T is spanned by, so all in this case. Okay. Kernel of T is the span of so I'm just repeating what you already told me. V1, V4, V7, V10. Image of T is the span of, and this is what we are doing now, V1, V2, V3 is missing, V4, then
V5.
V5, very good.
V7.
V7,
V8.
V8, very good. Now that's 6 plus 4, right? See, usually you cannot just, these are, there are linear combinations are possible, and I cannot do such a counting business, right? But the whole point of having a canonical form is that it enables you to count. See, you probably, okay, let me give you an example of what I mean. Okay, so if I tell you what is the rank of a matrix, what is the rank of a matrix in row reduced echelon form? What is the answer? What is
Number
the
of
answer?
non-zero rows.
Number of non-zero rows, right? Okay. What is the rank of a matrix if it is not in row reduced echelon form?
Number of linearly independent.
Number of linearly independent. So it is not equal to the number of non-zero rows, correct?
Yes.
Okay. So what the point of having, so what you see is that if I have it in row reduced echelon form, then the rank is just a matter of counting. I just count how many non-zero rows are there, and that is, lo and behold, that's your answer. That you cannot do for a general matrix, right? Similarly here, once, this kind of counting business, I cannot carry out if I'm given a general nilpotent matrix. Because I am supposed to take linear combinations. Some linear combinations could, it's a complicated thing. But in this case, it is sort of everything is very specially arranged. So you can do all these counts very easily. Just like you can say for row reduced echelon form, the rank is just the count the number of non-zero rows. That's it. Right? That's it. Nothing else. So similarly, the Jordan canonical form enables you to do all these counts very easily. That's the whole point. Okay. Okay. So, okay, right. So here, what should I write for? Okay, what is dimension of t square b? So what is dimension of tb in this number? In this color, what should I write here? What's the dimension of tb?
6.
6. Very good. Okay. What's the dimension of t square v? So let's calculate this further. So I'm going to write image of t square is span off. Okay. Now what do I observe? I have to apply t square, right? You've already applied t. You can use that.
V3.
V3. V3 is not even here, no? V3 is not even in the image. Image of t square must be a subspace of this. Image of t square is a smaller space than image of t. Anything in image t square is definitely in image of t. So it is going to be some of these. So let us just look at these and look at where they are going. V1 goes to, where does it go to?
0.
Where does V2 go to?
V1.
Okay. Where V4?
0.
0. V5?
V4.
Okay. V7?
0.
V8?
7.
V7. Right? So what is the image of t square?
3 dimension.
3. Dimension is 3. So the numbers here are 6 and 3. Okay. What are the numbers here in this case? So what is the dimension of the kernel? How do you calculate the dimension of the kernel in general? Suppose I ask you here, what is the dimension of the kernel?
So if you find the rank and then subtract from 10, we can easily find the rank because it's
how do you find the rank? Yeah, that's what we want. In fact, if you can find the rank, fine. Yeah.
So in the first
Here,
First
what's
two
the
black,
rank?
we have a two non-zero rows because 3, therefore we have two non-zero rows.
Very good. Yeah.
For the last 2 by 2, we have 1.
Okay, very good. So what is the
2 plus 2 plus 2, 6. No, yeah. 1 plus 1.
so what's the rank?
6. 6.
Here 6. Okay. And what's the t square?
Two.
Very good. 2. Very good. Let's just do it. Let's not ask how he did it. Let's just go ahead and do it. Okay. For this case, what's the rank?
5.
Very good. 5. Very good. What's the t square?
Is it 2?
Yes. Okay. This one.
4.
Okay. Maybe we can fill how many for this?
2, 3, 4, 5. 4, 5. And this one is 4.
So, let me write this. Just give me a minute. I'll just write this. Okay. So sorry, Anamale, go ahead. This was 4. You said?
Yeah.
Okay. This
3.
3. Okay. This.
Should be 2.
Yeah. Okay. This.
And should be 5. 4. 3. 2. 1. 0.
Very good. Okay. So
And
you've
the
done
above.
this.
Okay.
Let's do the other ones.
2, I think. Maybe you get 1. 1. 1. And this also 1. And the rest of 0.
Very good. Excellent. So we have worked out the possibilities, right? So can you tell me in general what the numbers are? So let me write a more complicated thing. So right. So if I write 100, let me write a 100. So 100 is too big a number. I can do for 100, but for illustration, what will be good? So let's write 11. Right. Right. So I'm going to write this 11. I'm not now in t cube equal to 0. I'm just going to write some partition of 11. Okay. So here I'm going to write 5. Okay. Sorry. Let me write a larger number. I'm thinking as we go along. Okay. Let me write 8 plus 4 plus 4 plus 3 plus 1. Is that 20?
No. So maximum entry should be 3.
I understand. I said that. This is not. I'm doing a different problem now. Okay. I'm just considering. So this is not anymore. Okay, I'm doing a different. I'll tell you what my problem is. So I give you this partition, right? Suppose so this is a new problem. Right? JCF 20 cross 20 matrix is given like this. You tell me what dimension of TB, T square V, T cubed V, T to the 4V, T to the 5V, T to the 6V, 7V, 8V, etc. Tell me all these dimensions, please. So V, let's start with V. V is, of course, what is the dimension of V? I hope you
20.
understand the problem, right? So I'm giving you a 20 by 20 matrix in Jordan canonical form, right? These are the blot sizes. Now you tell me these numbers.
20.
20. So this number, okay, I'll write it in this color. 20. Okay. What is TV?
15.
Let me see if that's right. I agree. Correct?
7
15?
plus 3 plus 3 plus 2 plus.
Yes, that's correct. T cubed V, T square V. It's taking some time now. What should you do? When will you have a contribution to T square V? Okay. Will this block contribute to T square V? 3 by 3 block. If I have a 3 by 3 block, I have V1, V2, V3. V1 goes to 0. I mean, this 3 by 3 block could be somewhere deep. So it's like, it's not, I hope you understand what I'm saying. This is some V8 plus then 12 plus. So we are talking about V17, V18, V19, and V20 here. You should not, let's not worry about that. Let's just look at this 3 by 3 block and call them 1, 2, 3 and see if it contributes to VT square, right? So V1 goes to 0, V2 goes to V1, V3 goes to V2. So when I apply T square to these vectors, what happens to V1?
0.
0. What happens to V2?
0.
What happens to V3?
0.
No.
V2.
V3 goes to V2, V2
V2
goes to V1.
Okay.
So V3 goes to V1, right? So if you have a 3 by 3 block, you will get a contribution to T square, 1. If you have a 4 by 4 block, how many contributions do you get? Okay. Or let's ask Annamalai. How did you get this 15, Annamalai? You were very quick in giving me that answer. How did you get that?
So the number of rows of 8 by 8 black, we have 7 rows, non-zero rows.
Right. Okay.
And then 4 by 4 black, we have 3 non-zero rows.
Yeah, that's a very good way of doing it. That's a very good way of yeah, but see, right, but then Yeah, I understand what you're doing. You can just count the number of non-zero rows because the JCF is already in row-reduced response, right? That's correct. But here now you have to take the t square of that. You have to take the square of that and count the non-zero rows. Okay, so you can do that also. So if you have a 4x4 block, when I take the square of that, what happens? What happened? We saw that here, right? Did we? No, we didn't write the square. The square will have, these two entries will be 1. Right? So each time you square it, it gets pushed further and further deeper. You can think in terms of matrices like that, or you can just think in terms of how many of them are becoming 0, how many are giving me other vectors. In a 4x4 block, so let me write it here. 4x4, if A is my 4x4 block, like this, right? What will be A square? Let's do it. V1 is already 0. V2 goes to V1 and V1 goes to 0 under A. So this is also 0. What about V3? V3 goes to V2 under A and V2 goes to V1 under A. So under A square, V3 goes to V1. What happens to V4? V4 goes to V3, V3 goes to V2. So you'll get 1 here. So how many non-zero rows are there?
2.
Okay. So in general, so the way you got this 15 is that there is a contribution of 7 from this, contribution of 3 from this, 3 from this, 2 from this, 0 from this. So it's 2 plus 3 plus 3 plus 7. That gives you 15. For the t square, what should I do?
6, 2, 2.
You should remove 2 from this. Yes, 6 plus 2 plus 2 plus
11.
1.
1.
11. Right, 11. Okay. And what about t cubed v? What should I do?
Subtract 3.
Subtract 3. So what do you get?
5, 1, 1.
This is 7. What is t to the 4v?
4.
4.
Then this 3,
3, 2, 1.
2.
0.
the rest of it. Okay, you see these differences. This is 5, this is 4, this is 3, this is 3, this is 1, this is 1, this is 1. So the differences keep decreasing. So this is a beautiful corollary. And so let me for a minute stop sharing the screen and share the tutorial sheet. Can you see this?
Yes, sir.
So here, if I do dimension of, okay, maybe I should read this in just one minute. Let me read this in. Okay. So I can write on it. I'll share a different screen for a minute. This will go away. Don't. I hope this is the right screen I want to share. Yes, looks like it is. So, no, I don't want to. Let me find the right screen to share. Just 1 second, please. Yeah, maybe this is the right screen. So you see here, dimension of V, PV minus dimension of, sorry, dimension of V minus TV is what? So these are some positive numbers,
Your screen
non-negative
is not
numbers.
visible, I think.
Screen not visible. Just 1 second. Yeah. Is it
Yeah,
showing
it's
now?
now visible.
Okay. Good.
Yes, sir.
What is dimension of V minus TV? If I subtract these formulae, so V minus TV, it's I. So here, I2 plus I3 plus I4. This is I2 plus I4, I3 plus I4, etc. Right? And then here, if I take dimension of TV minus dimension of T square V, if I take this, this will be I3 plus I4 and so on. Okay, so so what contributes to so you see this number, this difference is bigger than this difference. So that's what we saw in the other example. So the first difference was 5, then the differences have to keep decreasing. The differences cannot, first difference, if I start with 20, dimension of TV is 15, dimension of T square V cannot be 9, because the difference between 15 and 9 is 6, which is more than the difference between 20 and 15. Okay. Okay. So I hope, see, you might think that we covered very little today, but in my opinion, this was very successful. I would disagree with you if you thought that, because I strongly believe that mathematics consists of, I mean, it's not just a matter of belief. I think it's true that you have to solve problems. You have to engage with mathematics, right? Jordan canonical form is not not something you just read something about. It means something. You have to use it, right? It means something. So I think we did some. I would say this was the best lecture out of the 6 for me, because we actually tried and solved some problem and got our hands dirty. Right? Okay. Now, yesterday I promised that I would give out one more tutorial sheet by the latest by this morning. Now I haven't done that, but because I'm still working on that tutorial sheet. Right. So what I want to do is talk about cyclic decomposition and maybe rational canonical form. And I'll put up a tutorial sheet. Now we won't be able to cover it, of course, because the lectures are over, but I hope you will try it sometime, and if you have questions about it, you can contact me. Okay, so thank you very much for your attention. It's been a long workshop, 1 month, and thank you for your patience and attention. Thank you. Over to you, Professor Radha.
Okay, sir. Thank you, sir.
Okay, sir. Thank you, sir. So is it audible, ma'am?
Yes, sir. Yes, sir. Yes, sir. Gurusamy, sir.
Okay. So good evening to all. Let's start the valedictory function. And now I welcome Dr. R. Radha Jalakshmi, HOD Mathematics, to welcome the gathering. Ma'am, please.
Yes. A very good evening to everyone present here. I would like to extend a graceful and a warm welcome to all our most valuable resource persons, organizers, and participants for the valedictory function of the CMI NASI online workshop on linear algebra and elementary number theory. The active response of the participants across the nation affirms the relevance and the meaningfulness of this workshop. And I strongly believe that this has been a wonderful platform for our participants to enhance themselves in learning and solving problems in the core subject of mathematics. Now I would like to invite feedback from participants and all our resource persons. Thank you, sir. Over to Gurusamy, sir.
Thank you, ma'am, for your warm welcome. Now I welcome Professor Anirban Mogobadi, the academic convener of this online workshop, to give a report about our program. Sir, please.
Hello. So am I visible?
Yes, sir. You are visible, sir. Audible. Yes, sir.
Okay. Yeah. So I was the academic convener, but that was just a title. Whatever work was there to be done was done by Professor Gurushami and with support of Professor Rata Jayalakshmi. So I haven't done anything in organizing it. So I just simply lectured like other lecturers. So it has been a wonderful workshop. So I would like to thank everyone for participating and your patience and your time for this entire month. And yeah, feedback. So since it's a feedback, so I would say that it would probably be a bit better if you ask even more questions. But nevertheless, as long as the online platform goes, it was not. It was okay. So now the pandemic is coming to an end, at least officially ending. So we hope that the next meeting should be in person. So, okay, thank you. So I'll stop with that. Over to Gurushami.
Okay, sir. Thank you, sir.
If I may make a suggestion,
Sure, sir.
Anirban and
Yeah.
Guruswami,
yes,
maybe
sir.
Anirban can also say some few words after the participants have given their feedback, if that is relevant.
Yeah, sure. Thank you.
Sure, sir. Thank you, sir, for your kind words about our program. So now I request the participants to give their valuable feedback by unmuting yourself and give your suggestions, and then mute yourself for a better online communications. So your comments and feedback will be very helpful for us to conduct the upcoming programs in a fruitful way. So I urge you all to participate in this feedback.
In fact, your feedback is going to be much more important than my feedback. So please feel free to say whatever you wish to say.
A very good evening to all, sir.
Good evening, sir.
Am I audible, sir?
You are audible, sir.
Yeah. Thank you so much for the organizing team first. It was really nice. It was 1 month program. I don't know. First, I thought it was a very long workshop like that. But each and every day, I learn new things. It is very small, but it was very useful to me. So I enjoyed and learned a lot of new things in this lectures, sir. Thank you very much for that, sir. Thank you so much.
Thank you.
Thank you, sir.
Thank you. Could you identify yourself, your name and your affiliation, please, so that we know? Sorry, I'm unable to say it on Zoom. Yeah.
So myself, Jagadishan from Erode.
Thank you. Thank you. Which college in Erode or which university in Erode?
So I'm working in V8 Institute of Arts and Science, Dindal, Erode. So I know you personally. I have previously worked in K.S. Rangasamy College of Arts and Science.
Okay. Yes, now I
hope you remember me, sir.
Yeah, when you said Jagadishan, I thought it might be the same person. Okay, yes.
Yes, sir.
Tiruchengodu.
Yes, sir.
Okay, yes, I remember.
Okay, sir. Thank you, sir.
Professor, good evening, Professor.
Good evening, sir.
Evening,
Audible.
Sir, this is Dr. Venkatraman from Viluppuram, sir, working as assistant professor in Viluppuram ES Arts College, sir. We have already attended a MEPCO workshop, sir. Second time you are attending this kind of workshop. It's very really useful, and it is an updating our knowledge in the particular field, sir. It is very useful for us in the research, sir. I really congratulate team members, organizers who are organizing this kind of programs. I want to be in organizing team another event, sir, like this.
Thank you. But
Thank you, sir.
you should also criticize.
Yes, sir. Yes, sir. I'm a professor, sir.
No. I mean, you should. If you have any critical comment, you should put that forward.
No, sir. No, sir. This is a very useful program for us, sir.
Okay.
It's a very enrichment and several things I learned in this program, sir. Last MEPCO already they attended one CSR workshop, sir. That also we have attended. Similarly, this kind of workshop is very useful for us, sir. I also thank the organizing teams who are organize this kind of program, sir.
Thank you.
Thank you
Okay,
very much,
sir.
sir.
Thank you, sir.
So since Anirban, you emphasized criticism, here is a comment, my critique of my own lectures. It would have been helpful if the tutorial sheets were given much earlier than the last one. I'm saying it will be now given sometime later. I mean, it's the so that's not so good. But my defense is that I was preparing them as I was preparing for the lectures. That's my defense. But still, it would have been more helpful if the tutorial sheets had been given well in advance. So that's a criticism.
No, sir. Already we received 3 days earlier, sir.
I know, but yeah, the second one I sent you only yesterday.
Okay,
right?
sir.
And then the last one I have not even sent you. So, so no, I mean, you can condone it perhaps, but it is a criticism. Since yeah, no, I'm saying this so that people are free to. I'm also saying this because so that people feel free to criticize. I think Anirban means it really seriously because if you say what the drawbacks were, then maybe next time we could do better.
Yeah, I mean it's very important in fact. I mean criticism on any count actually, like the coverage, the way of presentation, usefulness. So I mean on all these you can say negative as well as positive things, whatever you have.
In addition, I also have a question to all participants to express their opinions, if they so wish, is what are the advantages or disadvantages of online versus physical? Now, online, of course, enables you to participate from the comfort of your living room or your study at home, and also allows people from very far off places to participate. So that's definitely an advantage. But we would like to hear from you whether to, if you have ideas about how to organize such things in the future, whether they should be online or offline or hybrid or something like that. Just to get you started off so that we can get more feedback.
Good evening, everyone. I think I would like to respond to what Raghavan sir had asked, like whether it would be online is more advantageous or offline. So in my case, like though we all are attending from various areas of Tamil Nadu or India at the comfort of our homes, but I feel like sometimes there are distractions that happen at home also, and we tend to, a little we do distract. It's my personal opinion. I had personally experienced that at some classes. So I think if it was offline, we are more concentrating, we are more towards the class than being at home. So this is my suggestion. And regarding the feedback, I think like being I'm a MSc student. So linear algebra and number theory are like core subjects of mathematics. So, and doing problems now, as Raghavan sir had emphasized earlier also, like nowadays problem solving is decreasing, but I felt this program has given me a lot of exposure on different methods and dimensions in approaching problems. So I would like to thank the organizers for giving this opportunity. So I thank all the resource persons too. Thank you.
Thank you, ma'am.
Thank you.
Could you identify which college you are from? You said you are a master's student.
Yes, sir. I'm from Chennai, from Stella Maris College.
Very good. Thank you. Your name, ma'am? I missed it.
I'm Saumini, sir.
Yeah. Thank you.
Thank you.
Thank you, sir.
Good evening to all. Sir, this
Good
is
evening,
my
sir.
Nagaraj. This is Nagaraj from Vivekananda College, Madurai. Sir, definitely it supports to us. All the lectures was very nice and encouraging one. So it's my opinion. It helps to learn more because of it was conducted by online. So even though we are working, it helps many convenient time to learn many things from the number theory and linear algebra. So it's my opinion, as a suggestion, it was nice through conducting an online. Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you. So
So
do
again,
you
Jagadish
mean
sir.
that? Do you mean that it's you don't need to take a leave from your institute and that's an advantage?
Yes, sir, yes, sir, definitely. We are currently working. We are not able to get more than 2 or 3 days work leave for
Exactly.
attending online programs.
Yeah.
Because of it was convenient to us to learn many things in the evening session and Sunday. So somewhat it is better to learn more by conducting these online workshops for a month. We are not able to get more than 1 week for offline classes. So
That's
that's
right.
why it was nice to us.
Yeah, if from that perspective, online is certainly a good idea. Yeah.
So again, Jagadish, I too support Nagarajan sir. As a faculty, we feel that online is very supportive for us. We won't get much time for offline classes. That is maybe 2 or 3 days only we may give. So this is very convenient for us. Online is.
So
Yeah,
if we have sorry.
No, go ahead. Go ahead.
No, I was just thinking that if we have a hybrid conference, but the timing is also an issue in that case. So since it was in the evenings, you did not need any leave, or your teaching didn't get disturbed.
Yes, sir. 100.
Yeah. So even if we have to have a hybrid, then so hybrid with evening lectures. So that might be difficult. I don't know.
So one more thing I would like to know your response on is the following. As it's made obvious, if it was offline, it would have to be morning till evening for 5-6 days, right? So
yes,
and that would mean you have less time to digest the material. Now you have 1 month over which this material is done, and you have gaps between lectures. So which means you can actually work out, understand, and then also see go back to the lecture on YouTube and see it. So I was wondering if that you think is a real advantage. I understand that offline has some advantages, as it was pointed out, that no distractions, particularly if you can make it to the offline event. Okay, but that's another question that I would like to know your views on.
Yes, sir. I Avik Singh. Excuse me, sir.
Yes,
you are audible, sir.
Could you just identify, meaning tell us your affiliation and the place you come from before you.
Avik Singh from Patna University, Patna. Sir.
Go ahead, sir, please. Thank you for that identification.
Yes, sir. And I got all this. My opinion, sir, that I got the opportunity because it was online, so I can attend, and I've learned the linear algebra also and elementary number theory. It was good, sir. Infinite continued fraction you have shown, that was very nice, sir. That topic I have seen. It was very good, sir.
Thank you.
Thank you, sir.
See any other comments?
So should we have a online feedback form as well? Like we can create a Google form and ask people to fill it up.
Yes, sir, we circulated, sir, through mail, sir.
Okay. Yeah, that may be a good idea.
Anirban, Guruswami asked me about this yesterday, and I said, yes, why not? CMI-NASI doesn't require us, but we had one for the TEW.
Yeah, exactly. So
I suggested that it be sent out, and I think it has been done as Professor Radha says.
Sure.
Okay, thank you all for your comments and the suggestions about our program. Now I welcome Professor K.N. Raghavan sir to say few words about our program.
No, I don't have much to say. I've been talking through 6 lectures, except that I really appreciate people from Anita ma'am from Ludhiana, from Singh Saab from Patna, and other people from other parts of the country who have taken an interest. This is really touching to see that there is so much interest in this. And so that is definitely one advantage of the online version of the events. Of course, as was pointed out, the offline has its own attraction as well. So, so it is, maybe we should do some offline and some online. I don't know. Anyway, so no, I don't have much more to say. The one thing that bears repetition, I keep saying this again and again, is that you have to solve problems. You have to do exercises. Mathematics doesn't consist of reading theorems from books. That is just not going to work. You have to engage with it, right? Think about, read one line from a book or Wikipedia or whatever source, and then think for every minute of reading that you do, perhaps several hundred minutes of thinking needs to be done. I mean, so several times it involves asking questions, appreciating questions, as I was saying, more than being able to solve the question. Can you appreciate the question? Why is the person asking that question, that particular question, right? Can I change, what is the point, etc. So this kind of engagement with mathematics is absolutely essential. And I hope you will tell your students, inculcate this habit in students. I really feel very strongly that this is something that we have lost in India, in most places where we just write out, state and prove, the theorem, the teacher comes to class and states a theorem and proves it without bothering about what the words mean. And then the same question is repeated in the exam, and people, students, write it out. And there is even the impression that this is, and they get good marks in the examinations, and they think that they have learned some mathematics. But so it is our duty, bounden duty, I feel, to do our bit to break this, to reform the system. Thank you. Thank you.
Thank you, sir. Sir, we are.
Thank you, sir. So, Anirban sir, can you please give your comments?
Yeah, so I don't have anything else to say. Of course, as Raghavan said, that Raghavan has already emphasized enough about this habit of solving problems to learn mathematics. So I would just say that about my lectures. So if you have further questions or if you want to know something related to that, or anything in basic number theory, you can write to me. I would help as much as I can.
Okay, sir. Thank you.
Thank you. So thank you.
Thank you, sir, for your kind support and guidance in organizing this event online at our campus. Now I welcome Mrs. A. Meena Kumari, local convener of this online workshop, to give vote of thanks.
Thank you,
Hello, sir. I have a question.
Ma'am, you are audible.
So, honorable resource persons, respected HOD ma'am, invited.
Hello, sir. I have a question. Can I ask?
Sure, sir. Ma'am, Meena, ma'am, please wait.
Is it okay?
Can I?
Yeah, sure.
You are audible, sir.
Please ask.
Okay, sir. My question is to Dr. K.N. Raghavan, who just told that to understand mathematics, you have to read word by word, and they solve lots of problems. But my question is to understand the problem, to understand the mathematics word by word, it requires so much time. So that time, little bit like I am I completed masters. I am preparing for PhD. So I trying to read like that in word by word, understanding every theory and every concept. But that requires many time, and in the consequences, frustration comes. So my question is to all the respected teachers, sets, and any other person. So how we can overcome that frustration, the time-consuming frustrations, to understand word by word and in-depth learning. So please help.
Anirban, you want to say something? I have something to say, but I'll wait for you to say if you have anything to say first.
Yeah, no, as I understand the question, the Raghavan has already given an answer to this. So just solving problem would make you understand things better. So you really don't need to read the theorem first to start solving problem. You can solve problem and use the statement and then go back to the proof. I mean, that's one way. Yeah, so over to Raghavan.
Okay, let me expand on what Anirban said. So see, I did say you should understand every word. That's correct. So if you take a book, so for example, linear algebra, right? You take a book like Hoffman and Quincy, right? So when I say understand word by word, I did not mean, so you start in page 1, read line by line, understand every word, think about everything for 10 minutes or even 1 minute, and then reach the end of the book, right? So that will take, indeed, as you say, a very long time and a lot of frustration. So as the saying goes, mathematics books are not detective novels, right? So this is, let me explain this strange statement. So a detective novel, if you start from the last page, right? You're reading, you want to enjoy a detective novel, you start from the last page. The fun is lost, right? The whole thing is to keep the suspense alive for yourself, right? You're playing a game, of course. You can go to the last page. Nobody is stopping you from doing it, but you will be sort of not have the pleasure of the suspense. The suspense is the pleasure, right? So you, is it making sense what I'm saying?
Yes, sir.
Okay. So, but mathematics books, Hoffman and Kunze, how many theorems does it have? Jordan canonical form is a theorem. Primary decomposition is a theorem, and maybe rational canonical form is a theorem, right? Once you so, for example, you can go directly to the Jordan canonical form, right? There are 2 pages of notes that I gave, where Jordan canonical form is completely described. So the point, so to answer your question, your question makes excellent sense. So I did say you read it word by word, but I'm not saying start from the first page and go to the last page, 329th page. I'm not saying that. Go to the theorem directly, as Anirban was saying. Just go to the theorem directly, right? Understand the theorem. The person writing mathematics textbooks, they have the theorems in mind, and then they build the, the notation, everything for that, right? So you have to somehow get to the theorem, get to the stuff, right? Cut to the action, as they say, right? So that is the solution of your problem. So indeed, what you say is, if you interpret my saying as reading everything line by line, word by word, yes, that's going to take too much time. But that's not what I meant, right? You don't have to write. You don't have to read too much. You just have to read that statement of Jordan canonical form. Think about it for 2 days or a week, right? You can close the book if that works out for you. Different kinds of things work for different, some of us, some things work, some others, some things work. For example, when I was preparing for it, I did not open any book. I just thought for myself. Of course, I have experience of this before, right? I've read some books and I've also lectured on this before. So I have some understanding of the material. So that's possible for me to do that. For you, that may be, if you are doing it for the first time, then that may not be possible. But just reading the theorem from the Wikipedia, or reading just my 2 page of notes, for example, tutorial problems, right? That may be good enough for you. So the answer to your question lies in not reading too much, reading very little. So this linear algebra that you have learned in one semester's course, can be written on 1 sheet of paper, all the theorems. And finally, that's all you need to know. So I hope, have I answered your question?
Yes, sir. It was very helpful.
Yeah. Okay. Good. Yeah. As Anirban says, do write to me or asking this question. If you have difficulty, I'm happy to help you also.
Thanks, sir.
Yeah. Thank you. Yeah. Thank you for asking that question.
Thank you, sir. So good evening to all. I deem it a great pleasure to propose vote of thanks on this valedictory function of CMI NASI online workshop on linear algebra and elementary number theory, organized by the Department of Mathematics, Mapkoshlank Engineering College, Sivakasi. First of all, I would like to thank the Almighty God for blessing us to gather together on this online workshop. I extend my thanks to the Chennai Mathematical Institute and National Academy of Sciences, India, for sponsoring the fund that helps to learn the deep knowledge on the subject. Then I thank the college management and our respected principal, Dr. S. Arivalagan sir, for being a supporting force behind us. I would also like to thank Dr. R. Radha Jayalakshmi ma'am, Head, Department of Maths, who graced us with her guidance and encouragement. Thank you, ma'am. I express my appreciation and gratitude to Gurusamy sir for his excellent coordination. Thank you, Gurusamy sir. Then I express my heartfelt thanks to Professor Anirban Mohabbatia sir for accepting to be the academic convener for this workshop. Thank you, Anirban sir. And my deepest gratitude to the resource persons, Professor Vijay Kodialam sir, Professor Anirban sir, and Professor Raghavan sir, those who have lighted the flame within us by sharing their time and knowledge with us. And the best kind of giving is Thanksgiving. I can't close the event without thanking the Honorable Professor K. N. Raghavan sir, because so with his guidance only this online workshop is possible at MEPCO, and his lecture on linear algebra refresh our brain since he makes the participants to interact. The words, sir, you said, but you appreciate the problem. It's very nice, sir. And you said by that professor creates interest to the participant. Sir, I expect your physical presence instead of online, and your journey with the MEPCO will continue in the upcoming years, sir. Thank you, Professor Raghavan, sir. Then I thank Professor Krishnan Hanamandu, sir, for offering us the technical support. I want to thank all my colleagues and supporting staff for their association. Last but not the least, I would like to express our sincere gratitude to the participants for their online presence because on hosting the workshop, in a Google form, there are around 800 participants has registered. So only we provide a YouTube link for them to access. So thank you for your response, wonderful response. And all special thanks to the Anomaly sir, Anita ma'am, Balamurugan sir, Chitra ma'am for their interaction during the lecture. I'll thank each and every participant. And my big thanks to the family members of resource persons, conveners and participants for their patience and support to make us free to attend the online workshop because they are behind the screen of us. So thank you one and all for making this workshop a success. Thank you. Thank you, sir.
Thank you, ma'am.
Thank you, ma'am, and thank you all. See you again at some offline program at MEPCO campus. Thank you, sir.
Yeah, see you.
Thank you, sir.
My thanks to MEPCO, really, Radha Jalakshmi ma'am, Meena Kumari ma'am, Goswami sir.
Thank you, sir. Thank you very much, sir.
Very nice of you. Bye.
Thank you, sir. Bye, sir. Bye. Thank you. Anirban, sir, thank you so much, sir.
Bye.
Thank you all participants.
Thank you, Meena madam, Goswami sir. Thank you, participants. Thank you all.
Thank you, madam. Thank you.